diagram from where we completed the second column of the stiffness matrix. Now you can see all your AMD matrix here. Now you can put all these values in the equation. Already we found the AML. Now we have the AMD also, and
सर
we have the
स्क्रीन
D
शेयर नहीं हो
also.
रही
Multiply them, and this way we
सर स्क्रीन नजर
find
नहीं आ
all the AM values.
रही सर वी कांट सी स्क्रीन
Huh?
सर स्क्रीन नजर नहीं आ रही स्क्रीन
Screen नजर नहीं आया. अच्छा, okay, okay.
यस सर
सर वी कांट सी द स्क्रीन
Okay. Can you see it now?
यस सर
Okay, I'll have to go back then 2-3 slides so that you can understand. Okay, from here I started. AMD 1 to 2 to 3 to you can see at joint B, at joint C again you can see this 4 to 5 to and 6 to. From where you will be getting these values? You will be getting these values from the sketch, which we already draw this for the generation of the second column of the stiffness matrix. And accordingly, you need to pick its values from here. यहाँ से आप उठाएंगे ये values BC के लिए. These are the values. So now this will complete the second column of the AMD matrix. So AMD matrix second column is completed. Now we put all these values in this basic equation. AM is equal to AML plus AMD times D, and product this addition, and we get all these values, and we put them on the sketch now. So AM1 is 6 point this one, AM2 11.8, and so on. Now, as a matter of fact, if you see, already we found this B joint moment and this shear and axial force for when we were analyzing the member AB. So we don't need to do these calculations again. This will be just the same numbers, but in the opposite direction. And if you see, already we have the same values there. If you go to AB, and at this joint B, if you see, we have this was downward 11.8, this was leftward 6 point, and this was counter, so this is clockwise. So here now at the right side already we found 1 kip per foot, and this is. So now we can draw the shear force and bending moment diagram. When we have the externally applied load, when we have the member and action, so we can draw the bending moment diagram. So this is the bending moment diagram. And after this, we draw the combined shear force and bending moment diagram. Going to the next problem, it's H. It's a H-shaped frame now. Leftward, if you see, the columns are having designation A, B, C. Rightward from the top D, E, and F. 12 feet, 12 feet, each column height, and horizontally we have 24 feet. Again, if we neglect the axial effect, so rotation at B is becoming the unknown, and rotation at E, that is becoming the unknown. So analyze the given frame using stiffness method now. So take EI is equal to constant, and this kinematic indeterminacy is 2 degrees, which is rotation at B and rotation at E. Now, if you see here, from here you should be able to see that for generation of the ADL matrix, 3 members will be now contributing: BC, BE, and BA. And similarly at joint E, again 3 members are connected, so 3 members will be contributing. Similarly, for the generation of the stiffness matrix, also the 3 members are contributing. They are connected at the joints. Now, let's rotation at B, we designate that by D1, and rotation at E, we designate by D2. Now corresponding to D1 and D2, we don't have any externally applied moment. So AD1 and AD2 will become equal to 0. So D1 and D2 are unknown, and now AD1, AD2, as I said, they are equal to 0, 0. So step number 1 we completed. Step number 2, now generation of the ADL matrix. So ADL matrix, you see here fixed end actions we need to find out. So B joint, now we have split now for each member here. BC, you see that 24 feet. BC, you see that I think it was 12 feet, and AB was also 12 feet. So those dimensions are not written, but you can see here. Similarly, ED, and this is B and C, B and E, we have made them fixed now. So this is the fixed end actions. Now corresponding to ADL1, whatever is coming from this BC member, from BA member, and for BE member, that will become our ADL1 value. Fixed end moments we don't have in member BE. Why? Because there is no laterally applied load. Similarly, for AB member, we don't have any laterally externally applied load, so that is also equal to 0. For BE, we have WL square divided by 12. W is 2. L is 24 divided by 12. So this is coming counterclockwise 96. So now ADL1 will become equal to 0 plus 0 minus 96. So minus 96 is becoming this ADL1. ADL2 is equal to this plus 96 plus 0 and plus 0. So plus 96 is coming here. Now let's say here was a pointed load in BC. So for that case, you will have to find out by using that PL equation. And you need to find out this moment. Now the moment here created will be counterclockwise. So you will have to add that algebraically with this 96. For AB also, we were having some lateral load. So it will causing the member and moment. And you will have to add that to this 96 moment then accordingly. And same is the case for joint E also. So now you can see member BC and BA, they are not contributing. Why? The reason is because they don't have any lateral loading. If they have the lateral loading, then accordingly you will have to find out its value and you will have to add up with this 96. And similarly for the joint E also. So this is how we create this ADL matrix. Next, now we generate now the stiffness matrix, and to create the first column of the stiffness matrix, what we do at joint B now, we give a unit clockwise rotation. Now you see here, this is going to be the deflected shape. Your deflected shape can be this way also if you follow this cursor. But why? That will be the case when we give it a counterclockwise unit rotation. But here we are giving a clockwise unit rotation. So how it is clockwise? If you draw a tangent here, so you see here it is clockwise and this rotation is also clockwise. Similarly for the horizontal member, if you see this distorted shape, so again if you see this is clockwise. These orange arrows, this is showing you the direction of the unit rotation now. And this is how the structure is going to be deformed. At E, if you see, we are now not allowing any kind of displacement here. So you see a fixed support here, this fixed support. Now, these E member, the horizontal member at the near end, 4EI over L, L is 12. Far end, it will become 2EI over L. The balancing couple here, you can see 6EI 24 and 6EI over 24 square. Now, AB member, near end is this one. So 4EI over L, L is 12. Far end 2EI over 12. And here it was clockwise. So the balancing couple now, it is clockwise. So this balancing couple, this direction is wrong now. It is clockwise. So this should be counterclockwise. So we need to change this. This should be the other way now. Or what we can do now smartly if we want to change now. So if I disregard this, you can make these changes. What I do now, we flip it here, and the other one we need to bring it here, but it is where it is now This one we need to bring it. And similarly, this will be causing clockwise, and this we need to now do the other way. So it should be coming this way. And similarly, you can make the adjustment to the top one also. This is clockwise, so this is counterclockwise. So this one is correct, but only this one was wrong. And you can make it straight also. So this is now the right position. Similarly, for the BC, it's the near end. So 4EI over L. So this is becoming 4EI over 12 because this was also 12 feet. Far end it is 2EI over 12. And similarly, you can find out this balancing couple, which should be counterclockwise. Now, the S11 will be at this joint, the summation of the member and moments now at this joint. Why moments? Because moments are corresponding to D1. So 4EI over 24 plus 4EI over 12 plus 4EI over 12. This will become your S11. We should make a note of this one so that we go to the next slide. You should be looking at these three components: 4 over 24, 4 over 12 plus 4 over 12. These four EIs come. S21 will be just this 2EI over 24. So that will become 2EI over 24. So next slide when we go, so here you see 4EI over 12 plus 4EI over 12 plus 4EI over 24. This was from the horizontal number. And the S21 is 2EI, and you can see here now in these decimals. Now, second column. So second column, what we do corresponding to D2, now we give our unit rotation. Here again, you can see and verify this clockwise rotation. Here you see this is the distorted shape. Clockwise for here clockwise and for here clockwise also. At one, we need to now fix it. We are not allowing anymore. Again, for BE, this is becoming, E is becoming the near end. So 4EI over L, 2EI over L, 6EI over 24. Signs and each and everything now you can verify. Now here this was clockwise, so this is becoming counterclockwise balancing couple. Here again clockwise. So these direction cannot be like this. Now it should be a couple. Couple means in opposite direction. So means if it is clockwise, so counterclockwise means it should be in this direction. This one if I pick. No, this one. Anyways, you can drag it back to the. So this is now the couple in the. And here, if you see this one, this is again a couple for to balance this unbalanced moment. This unbalanced moment is going to be balanced by this couple. Now S12 is 2EI over 12, so make a note of this, 2EI over 12. And your S22 will become equal to 4EI over 12 plus 4EI over 24 plus 4EI over 12 and plus 4EI over 12. So S22 is 4EI over 12 plus 4EI over 12 plus 4EI over 24. Combination of the summation of these three all are in clockwise direction. So this way now, if we go back, this way now it's to 4EI4. So this is how we get it. And now finally we go and we write over this stiffness matrix. Now AD known, ADL known, and S known. So we can again write the simultaneous equations. Their standard matrix form, condensed form of the equilibrium equation, and then rearrangement of this equilibrium equation for the solution of unknown D's. We plug in the values and finally D1 and D2 we found. So these are now the D1 and D2 values. And now accordingly then you can go. So quickly now you can now write these moments and these things, and you can verify by using the this AML for each particular member. I'm not going to revise it for this one because I went through the basic two problems, that how we find out the member interactions. So from here you can verify by taking these, and you can the directions are given, its magnitudes are given, so you should be able to verify these values for each member, and then you can draw the shear force and bending moment diagram. Next problem, which is problem number 4, and it is going to be the final problem now for today's lecture. Quickly, now you go and draw this one because it is having UDL, it is having the pointed load. The pointed load is not centered, it is eccentric now and on this member AB. So quickly draw it, and quickly we will run over the these calculations. A, B, C, D, we have a frame. AB, at A we have a fixed support. B is a joint connecting 3 members, and it's a rigid joint. BC is carrying a UDL of 3 kip per foot. At C we have a hinge support. At BD member does not carry any load, or I mean horizontal load, but at D we have a fixed support now. AB member is 15 feet. BC member is 20 feet, and the vertical is 10 feet. Now in AB member, 5 feet from support A, we have 60 kip pointed load. This is the description of this. Now if we ignore the axial effects, A cannot allow any rotation, D cannot allow any rotation. Now B joint cannot come down because of this member BC, because we are ignoring this effect. Similarly, if you see B cannot go to the left and right, so their translation is stopped because of BC and BA members, because we are ignoring the axial effects. But joint B can rotate now. It will be a rigid joint rotation, and at C also it can rotate. So theta B and theta C are becoming our unknown joint displacement. So we declare this problem as a kinematically indeterminate 2 degrees problem. Now D1 and D2, these are our unknown joint displacements. You can see the structure. How we fix it? Just at B we put a fixed support, and just at C we put a fixed support, and that gives us a restraint structure. Corresponding to D1, we don't have any externally applied moment. At D also, we don't have any externally applied moment corresponding to D2, I'm saying. So we declare them 0 and 0. D1 and D2 are unknowns. Now, this is now the restraint structure. As I said, here we are putting at B fixed support, and at C also we are putting a fixed support. AD matrix we generated. AD1 was 0 and AD2 is also 0. Now, the ADL matrix we need to generate now. So this is how now we split them at joint B now into fixed ended B. Here you see PBA square and PAB square divided by L square. That equation we are using in finding out these fixed end moments. Reactions we found, you can verify these from the fixed end equations. Now for BC member we are doing, and then BAB does not have any, so these are becoming our 0 and 0. ADL1 will become coming to the A1 location now, so we have plus 66.67 and minus 100, so minus 100 plus 66.7, so this is giving minus 33.33. Corresponding to D2, which was here, we have plus 100, so we have plus 100 here. Next, we now generate the stiffness matrix 2 degrees indeterminate. Corresponding to D1, we are going to allow a unit rotation, so corresponding to D1 here, rotation is allowed. And if you draw a tangent here, so you see here clockwise and clockwise at theta1, and this member is going to deflect this way. If you want to deflect it this way, this will become counterclockwise. So this will be counterclockwise then. Now, so now our S11 will be coming corresponding to this one location now. So we have point 2. How this point 2 is generated? It was 4EI theta divided by L. Far end 2EI theta divided by L. Similarly for this number and for this number. So our S11 is 0.2 plus 0.4 plus 0.267, which you can see here, EI. And our S22 is 0.1 EI. Let's verify this value. This length is given. So this is 20. So this will become 4 times 20, 4 EI. So 4 divided by 20 actually. And it is 0.2. So 0.2 we have here. It will be half of this 0.2, so 0.1. Let's verify this one. So this will become 4 divided by 10, so which is 0.4. Let's verify this one. So this will become now 4 divided by 15, so 0.267. So we see 0.267. Far end it is going to be half. And similarly, you can find out the balancing couple also for each one. S11 is how much? Okay, this was S11 we already talked about it. S21 is simply this 0.1 EI. Now corresponding to D2 we are going to give a unit rotation. So here in clockwise direction, this is the distorted shape. This is 0.2 EI. From where it is coming? 4 over 20 EI it is coming. And here it is half of that. So now our S12 is 0.1, which is written here, and S22 is 0.2, which is written here. So now we have this. We have generated our stiffness matrix now. Now, coming to the equilibrium equation, so still we have this the same equilibrium equation we are using. Now we put the values in equilibrium equation and solve for the unknown joint displacement. So the joint displacements we found. Next, we go compute the member and actions and draw the shear force diagram, which is a routine method now. So you should be able to do these things. Now coming to the assignment now, find the member and actions and draw the shear force and bending moment diagrams for that H frame we did and just the frame which we for problem number 4 we did. So you will have to draw the shear force and bending moment diagram, and for that you need to find out all the member and actions. And then analyze the frame given below using the stiffness method. So you need to coordinate with engineer Faisal about all these assignments and these things. If he's giving you more, so it's okay, you should be able to do more work now. So this is now these two problems at least you will be having for your home assignment. And this is also assignment 4A and 4B. So we have question number 1, assignment number 3A. So 3A we have question 1 and then assignment 4A we have this problem, and you will be now solving this problem also. It's 1:30 now. We have still 10 minutes, and now you can ask me questions if you need any clarifications or if you need more now explanation. You can turn on your mics and we can discuss now this. Let me check the slide number. It is slide number 94. Up to slide number 94, if you have any question, now you are most welcome now to ask these if you have anything. If you don't have any, Mr. Mohammad Noman,
Yes, sir.
you have something, some problem with your mic. I cannot hear you. Again and again, you are trying to
Yes,
say
sir.
something, but I cannot hear you.
सर माइक में थोड़ा प्रॉब्लम है सर.
Abdul Musawir, do you have any question?
No, sir.
Clear?
Clear, sir.
Faryal, do you have any question? Uzefa, do you have any question?
No, sir. कोई question नहीं है.
Okay, so I think we are fine then. We are going to now end this class here at this point. But now remember, we need to go for more complex problems, which will be involving the side sway now when the lateral deflection is there. And that is going to be more complex. So next week, inshallah, that will be the topic of discussion. More complex means you should now cover whatever we have till now for the non-sway problems. For these frames where we don't have any sway, because this will be also running in the background. From beams, we went to the analysis of frames without sway, and now the sway problem, it will be a little bit more complicated. It will not be complicated if you know the whatever we did already for the beams and for the non-sway problems. One thing now, we need to decide about the YY exam also. And this is a good point to talk about the YY exam. So when we are going to take the YY now, Numan, if you can share with me in writing, because I cannot hear you. So if you can write me, because we need to arrange a special class now for the YY.
सर वो आप इंजीनियर फैसल डिसाइड कर ले, स्केड्यूल अपडेट कर ले तो हम कर लेंगे सर उस दिन.
When shall we have YY now? Okay, why don't you decide timing with CR? I mean with the TA, Mr. Faisal. Numan, if you can hear me, you coordinate with your class fellows. Fix a time. It can be in the evening, or it can be during the regular working hours. You fix a time, but make sure it is not tomorrow from 8 to 11 o'clock, because from 8 to 11 o'clock, I have a class with section A. So you fix a time, we will sit, and then you finalize it with Mr. Faisal Parvez. And he will let me know that this time we are going to have the YY. So each individual will be coming on, we will fix like what will be the method for taking this YOC exam. So you finalize this with Mr. Faisal Parvez, and he will let me know, and then we will sit accordingly to finalize this YY exam. Okay, thank you so much for now.
Okay, thank you, sir.